Okay, so in this section it says to identify the form of the equation and two characteristics of the function's graph. So for example, this first one is in slope-intercept form. Of linear equations. And we could identify the slope and the intercept from this. For y equals mx plus b, we're looking at the slope, and the b, or 0, 2, is the y-intercept. So that's what they're looking for here, for you to say what's the form and what are a couple things from it. This one is in point slope form. That's going to be y minus y1 equals mx minus x1. And then two identifying characteristics of this, again, could be the slope. And instead of having an intercept, this one has any x1, y1 critical point. So the critical point, or x1, y1, of this one would be 5, -2. You see it right here? Okay, next it says, what is the average rate of change for this quadratic for the interval from x equals 3 to x equals 5? So again, we're looking from here to here. So if you're looking at the change in general, from a 1 to a 2, from a 2 to a 5, from a 5 to a 10, you're starting to notice that this is jumping by every odd number, which has a common difference of 2. And then when they say what's the jump from the 3 to the 5, from a 10 to a 26, that's a jump of 16. But how do we actually calculate? Let's do the slope formula. So we're looking at 310 and 526. So here I go. This is your x1, y1. This is your x2, y2. And you're going to go y2 minus y1 over x2 minus x1. We use the slope formula to calculate average rate of change. And since it's a jump of 2 from 3 to 5, we're looking at an average rate of change of 8. So the answer is 8, average rate of change. Okay, what is the average rate of change for this exponential function for the interval from x equals 2 to x equals 4? So again, we're looking at these two pairs, 216 and 4, 256. Slope formula, so that's going to be 240 over 2, or 120. So this time our average rate of change is 120. All right, what's the average rate of change for this quadratic function from the interval from 0 to 2? For this next one, number 5, the graph is on the next page. So those of you taking notes, you can just sketch this out. But from 0 to 2, we're just looking from here to here. So the jump is from this dot to this dot. So it's up 1, 2, 3, 4, and over 2. We just counted on the graph. Average rate of change is just 2. What is the average rate of change for this exponential function on the interval from 2 to 4? So again, right now we're going from 2 to 4. We're going from this dot to this dot. And so from 2, 4 to 4, 16, we're doing the slope formula. And our average rate of change is 6. Use the pattern shown in the tables to predict the average rate of change for the function for the specified interval. So from 11 to 12, and then they're asking, 12 to 13, they're asking for 14 to 15. So if you just continue the table, you're going to notice that this goes another 2. So this would be down 13, this would be down 15, this would be down 17. So average rate of change of this guy right here would be a move of 17. average rate of change in the interval from 8 to 9 for this one. So 5 to 6, 6 to 7, 7 to 8, 8 to 9. If we just continue the table here, and again, you're noticing this common second difference, this one right here is multiplying by 2. So 32 times 2 would be 64, 128, 256. How'd you do on those? Okay. Identify the x-intercepts and the y-intercept and the vertex of the graph. So for the y-intercept, it's just our c value here. If you plug in 0 for x, you just get the c value. So 0, 20 is our y-intercept. For the x-intercepts, let's divide out a 2 here. And notice that this inside part is now factorable of 2 times 5. So x plus 2, x plus 5 are the factors. So that means that x plus 2 equals 0 and x plus 5 equals 0. So x equals negative 2 and x equals negative 5. That means that my two x-intercepts are negative 5, 0 and negative 2, 0. Those are my intercepts in intercept form. Finally, the vertex of the graph. We can do our little vertex baby formula. And so we go negative 14 over 2 times 2. That's negative 14 over 4. That's negative 7/2 in our reduced form. So this is the x of our vertex. We now need to plug this in to get the y. I'm going to use this space up here. So y equals 2, negative 7/2 squared, plus 14 times negative 7/2, plus 20. So 2 times 49/4. Let's get a calculator for this one. 14 times 7. And to put this into fourths, it would be 80/4. And let's put this into fourths. And then 98/4 right here. So 98 plus 80 is 178/4 minus 196/4 is going to give us negative 18/4 or negative 9/2. So negative 7/2, negative 9/2. Is that really how ugly that answer is going to be? Yep, that's the answer. You can also put it in decimal form, negative 3.5, negative 4.5. All right, so we got the x-intercepts right here. We got the y-intercept right here. And we got the vertex over here. All right, the y-intercept and whether it's increasing or decreasing. So notice this is a 3/4 or a fraction for your multiplier. So it's decreasing, getting smaller as it goes. And then the y-intercept is 3.